Hello my friends and welcome again to the implementation of our deep convolutional Q-learning model AI of part 2, which we will be implementing for the Pac-Man environment. First of all, I hope that you made sure to create a copy of this partial code notebook you got from that link I gave you previously. And second of all, well, I hope you took the partial code so that we can implement our new AI together just like before, This partial code notebook contains only the codes that are not essential to building an AI, not related to building an AI. So it will contain the code that installs the Gymnasium library, just like before, that imports the libraries, and then that visualizes the result. And this is exactly the same code as before, only the name of the environment changes, okay? And of course, in this new part 2, we'll implement all these cells, starting by creating the architecture of the neural network, and then we will set up the environment, initialize the hyperparameters, pre-processing the frames, implementing the DCQN class, deep convolutional Q network class, initializing the DCQN agent, training the DCQN agent. Alright, so that's all we'll do in this new implementation. And the good news, actually, is that for most of the cells here, well, they will be very, very similar to the cells we implemented in our deep Q-learning implementation. Indeed, as you notice, this is the exact same structure, right? We start by creating the architecture of the neural network, and then in part 2, training the AI. If you look closely, well, we have the exact same series of steps here, setting up the environment, initializing the hyperparameters. However, we won't be implementing experience replay, but we will still have a memory for our AI, and we will just use an append function to store the different experiences. I'll show you how we will adapt this. But then, of course, we will implement the DCQN class and initialize the DCQN agent, training the DCQN agent, all right? And you will see that the codes for each of these cells, for each of these steps of this part 2, training the AI, will be extremely similar. So actually what we'll do is not re-implement all this. We will actually take from our code here and then just adapt to this new code, okay? Because you will see that even in those big codes like this one, that implements the DCQN class, or this one that implements the training for loop, well, we will only have 2 or 3 things to change. So as AI scientists, of course, we want to do this efficiently, and so that's how we'll do it, all right? So let's do this. Let's get it started. We're going to start by executing this first cell to install Gymnasium, right? Because we are in a new session, so we are in a new notebook in which Gymnasium is not installed yet. And there we go. Now it is installing, collecting Gymnasium, downloading Gymnasium. Then remember, it downloads all the dependencies like Pharma notifications and also Box2D and the other ones, Pharma notifications, Gymnasium. There we go, Gymnasium, and requirement already satisfied. That's probably because I was working on some other notebooks before in this account, but there you go, downloading AutoROM and other build dependencies. Perfect. Requirement already satisfied. Downloading another dependency here, installing collected packages, successfully installed AutoROM and build dependency. Okay, good, successfully upgraded. I can't follow. Downloading again Box2D, and there we go, build wheels for collected packages, Box2D PY. And in a few seconds now, because this is the last step, remember, in a few seconds now we will have all the Gymnasium packages and dependencies that we need to run our Pac-Man environment. All right, just like before. So it's going to take a couple more seconds, and then we'll be good to go to build our environment and, most importantly, build our AI, our deep convolutional Q-learning model, playing just like a human the game of Pac-Man with its own eyes, represented actually by the convolutional layers in the deep convolutional neural network. Alright, so this is of course much more complex and much more advanced than what we did before, but you will see that we will get good results at the end, because indeed we will be able to achieve a good score. What do we have here? Successfully built Box2D PY, installed collected packages, and all good. Successfully installed Box2D and Gymnasium and everything. We are all good to go. Now let's import the libraries before we get started with part 1, building the AI and creating the architecture of our neural network. Now a convolutional neural network, because our AI will have eyes. So there we go. Let's import those libraries importing Torch now, importing Optim, the Optim module, the NN module, neural network, the functional module to, use the activation functions, and the loss function, remember, for the training, and the and data loader and tensor data set. So once again, as you can see, this is the beauty of Google Colab. We didn't have to run some pip install commands in the terminal to install any of these libraries and modules. So we only had to install Gym, but this is done. This worked perfectly well. And now we're good to go to build our AI. And by that, we mean, of course, creating the architecture of our convolutional neural network. All right, let's get some good energy. It's going to be a big code, of course, because we have a lot more layers than before. So get some good energy, get a good coffee, and as soon as you're ready, let's meet in the next tutorial to implement this. And until then, enjoy AI. Hello my friends, and welcome to this new step of this implementation. A very exciting step, because this is basically when we build the brain of our AI, but not only the brain this time, but also the eyes, because we're going to bring into the neural network some convolutional layers which will act as eyes in order to be able to see the input images from the game, which are nothing else than the states. All right, so we have a lot to build, we have a lot to architect, so let's do this. Let's fire away. So we're going to create a new code cell, and just like before, we're going to create a new class, which will be the network class, and which will inherit again from the module class by the NN module. So we call the NN module first, from which we call the module class. All right, and that module class is actually the base class for all neural network modules in PyTorch. Okay, here we go. Let's define the class now. And as usual, we're going to start with the constructor method, the init method. So here we go. Let's define that init method. All right, so our init method will take self as the first argument for the object. Then it will take the action size. And however, it will not take, like before, the state size, because this time the state is an image. It's not a simple one-dimensional vector. It's a multi-dimensional array representing the images, besides in 3 dimensions, with RGB. So we cannot simply enter the state size here, even though there is a state size, we will compute it afterwards. But basically, we will just need the action size for when we create an object of our network class, an instance of our network class. So action size, and then, however, just like before, we're gonna set a seed with a default value of 42, just to ensure reproducibility. Okay? All right, so now let's initialize all our object variables. But first, before we do this, remember what we have to do in order to activate the inheritance from the module class by the NN module. Remember we do this? Well, actually this time Google Colab didn't help us. I think that last time it helped us. But basically we call the super function, which takes as input first our network class and then our object self. And then there we go. Then we just add a dot and remember the init method. All right, just like that. This is just in order to call the initializer of the base class, meaning the module class by the NN module, to correctly activate the inheritance by setting up the internal state of the class, okay? So no need to understand more details of it, just know that we have to add this line, and then now we define our object variables. So according to you, what is going to be the first one? Let's start with the easy one, self.seed, which remember we initialize by calling first the torch library, from which we call the manual seed function, which takes as argument, well, the argument we input here, the seed. All right, just like what we did in our deep Q-learning class. All right, so now let's go back and next step, next object variable. So actually the next step now is where things get interesting, because this is exactly now that we start building the brain, including the eyes of our AI, the whole neural network. And according to you, what is going to be the first operation here? The first connection or convolution. I'm just giving you some hints here. Well, of course, the first operation is going to be a convolution, right? Because the eyes come first before the fully connected layers of neurons in the brain, all right? Just like a human, the information, the signal comes first through the eyes and then it will go through the brain. And so here, that's exactly how we're going to build it too. We're going to start with the eyes. And so the next object variable I'm initializing here is going to be our first convolution, which I'm calling conv1. Okay, and how do we create it? Well, by of course calling the NN module, from which we are going to call the conv2D class. Okay, so conv1 will actually be an instance of that conv2D class. All right, and now very important, what are going to be the arguments of this conv2d class? Well, first, it's going to be the input channels. And since we're going to work with colored images, we're going to choose to have 3 input channels corresponding to the RGB channels of an image. So here we go. That's our first argument, 3. Then the next argument, as you see, is the number of output channels. And there is no rule of thumb right now to choose the optimal number of output channels. Just know that there has been a lot of experimentation to make this AI work on this Pac-Man environment. And well, a good number, probably not the optimal number, but a great one that leads to good results, is 32. Okay, so 32 output channels. Then the next argument, as you see, is the kernel size. And again, after a lot of experimentation, we find out that a good kernel size is 8 by 8. So I'm adding here kernel size equals 8, but that means we will use an 8 by 8 kernel. And finally, the last argument here will be, this time Google Colab doesn't highlight it, but it's going to be this one, the stride. All right. And again, after a lot of experimentation, we find that a good stride value is 4. All right. And that's our first convolution of our neural network. Congratulations! We have just built basically the first layer of the eyes of our AI. Of course, these are not the full eyes because we're going to make other convolutions, actually 3 more, with besides some batch normalization layers. But there you go, we have just architected the first layer. So congrats still. All right, now next step. So the next step, as I just said, is to define now a batch normalization layer for 2D inputs. And why do we add those? Well, that's because they will help in faster and more stable training. Okay, so that's very powerful in a convolutional neural network for training purposes. Okay, so let's add this. That's our next object variable, which we're going to call bn1 for the batch normalization operation. And again, our self.bn1 object variable will be created as an instance of a new class, which will not be the conv2d class, but of course, as you might guess, the batch norm2d class. So there we go. We call our NN module first, from which we call this batch. There you go. You have it here, batch norm2d class. And now, very simply, according to you, what will it take as input? We actually only have to input this one, the number of features. Well, just like when we do the full connections, it's basically the number of channels or feature maps in the previous layer. And well, the previous layer is a convolutional layer of 32 channels or feature maps. And therefore, that's exactly what we have to input here, 32 channels. Okay, great. So now we're going to do 3 copy pastes because we will actually create 3 more series of a convolution followed by a batch normalization operations. And so there we go. Let's get those 2 lines of code, and just below, let's copy them 3 times. Okay, and now we'll just change the parameter values, meaning the number of channels and kernel size and stride inside each new pair. So let's start with the second pair, this one corresponding to the second convolution and the second batch normalization. And so here we go, let's do this together. So here, for the number of input channels here, what do you think it's going to be? Well, of course, it's going to be what we have here, 32, okay? Then, for the number of output channels in this second convolution, what do you think it's going to be? Well, you can't really guess, but again, it's after a lot of experimentation. We find that a good number is actually 64. But again, there is not really a rule of thumb. What matters is that we gradually increase the depth, meaning the number of channels, while decreasing the spatial dimensions. So the number of channels will be increased through the different convolutional layers, while the kernel size and the stride will be decreasing. Then, what do you think is going to be the kernel size? Well, again, you can't really guess, but a good one is 4. And then what about the stride? Well, same, you can't really guess, but a good one is 2. Okay? For our particular environment with this particular AI that we're building. Okay? So, now, however you can guess it, what is going to be the number here for the second batch normalization? Well, of course, it's going to be the number of output channels in our second convolution, which is, of course, 64. So that we can guess no problem. Then, let's take care of the third convolution, self-conv3, and the third batch normalization. Here we go. So, you can guess the number here. What is it going to be? It is going to be, of course, the number of output channels or feature maps that we have here. Therefore, 64. Then, according to you, what is going to be the number here? Well, if we follow the logical sequence, we would be tempted to say 128, but no, there is no logical sequence here actually. It's still going to be 64. And again, this is just after some experimentation and hyperparameter tuning. Okay, so 64 again. Then, for the kernel size, well, again, after some hyperparameter tuning, we get that a good kernel size here is 3. And then for the stride, same, a good one is 1. Okay? So that's for the third convolution. Now what about the third batch normalization? What is going to be the number here? That you can guess, of course, is going to be the number of output channels in the previous convolution, meaning 64. Alright, great, we're almost there. We're almost done with the eyes of the AI. Are you excited to be able to build such advanced things? I think this is very exciting, and plus, PyTorch makes it easy to build. So here we go with our final convolution, conv4, with the final batch normalization bn4. First, we can guess the number here. What is it going to be? It's going to be, of course, the number of output channels or feature maps in the previous batch normalization layer, which is therefore 64. Then, according to you, what is going to be a good or hopefully optimal number of output channels here in this fourth convolution? Well, remember, we want to gradually increase the depth, meaning the number of channels over the convolutions. And so since we didn't do it for the previous one, well, we're going to do it here, and we're going to add 128 output channels. Okay, so now what is going to be the kernel size for our final convolution, conv4? Well, same as before, a good one will be 3, and then for the stride, again, a good one will be 1. Okay? And finally, what is going to be the final number of channels here or feature maps? Well, of course, it's going to be that number here that we had in the previous convolutional layer, meaning 128. And that's it, my friends. Huge congratulations. You just built some artificial eyes for an artificial intelligence, which now, thanks to what we've done, our AI will be able to look at images, the images of the game, in order to understand what's happening in the game, and therefore play the game, and therefore win the game. Okay? But winning the game will be, of course, thanks to our implementation of the fully connected layers, which will be the layers that will be able to understand the logic, and besides, with the deep Q-learning algorithm that we will implement in the training for loop. Okay? So huge congrats again. That was very exciting to build this. Now we're going to take a little break, of course, and in the next tutorial, as soon as you're ready, we will build the fully connected layers of our neural network. And until then, enjoy AI.